So my name is Cieplak. I'm from Verizon Media. So today I'm going to be talking about Istio Mutual TLS and RBAC with an external CA. Now, just before I get started, I just want to tell you a little bit about our current production scale for Kubernetes. So we're running about 27,000 pods in production. We have a little bit over 900 applications with a little bit over 1 million peak RPS on the Apache traffic server layer. And we're also introducing Istio Ingress into our stack. So we have about 5K RPS there right now. Okay, so what are some of these goals of this project that we wanted to accomplish? So one of them is we want mutual TLS for service-to-service communication. Essentially, we have a lot of applications still on HTTP that are communicating with each other over it. So we want to move most of those to mutual TLS. We want to leverage Istio and Envoy as well. So essentially, we don't want all of these frameworks rewriting application code when we can leverage Envoy to just directly get some of these features. We want to also leverage an in-house certificate authority and PKI called Athenz, which I'll get into in a minute. And we also want engineers to basically easily define RBAC for service authorization. So what are some of the features of Athenz? What exactly is it? So it's a certificate authority. It provides short-lived X509 certificates. It has the ability to basically have per instance certificate management, meaning that essentially like in a Kubernetes environment, each certificate will be associated with, let's say, a pod. So essentially the UID of the pod will be as part of the SANs inside of the certificate. And it also provides role-based access control and also decentralized access enforcement, meaning that you can actually cache roles and policies locally so that you can do role checks as they're coming in without actually calling Athenz directly. Okay, so how does the Athenz data model actually look like? So here we have the Athenz UI in front of us. So at the very top, we have an Athenz domain. So that is essentially a one-to-one mapping to a Kubernetes namespace. We convert the dots to dashes for Kubernetes here. And each domain essentially has roles in it. And a role itself is a group of principals. And principals themselves are users or services that can be added towards that role. Now, on the other hand, we also have policies. So policies are essentially assertions on which actions are allowed or denied on particular resources. So here's an example. For example, you can either allow or deny specific action in the Athenz UI here. The get will be mapped to the action inside of the UI of the policy. And then in the resource, we will specify the domain and also the HTTP path. For example, here, API v1 get details. Okay, now that we have the Athenz data model, how do we leverage it to actually get it working with Istio mutual TLS? So what we've introduced to accomplish that is we have an Athenz sidecar to provide Athenz X509 certificates. These certificates are rotated every 24 hours with an expiry of about 30 days. And they all have the SPIFFE URI in the form of namespace/SA service account. And essentially these certs are shared with Envoy through an empty directory so that Envoy can pick them up and then refresh them, etc. And we're also working on supporting the Envoy SDS API so that none of these certificates are actually written to disk and everything stays in memory. And then in general, these certs are essentially used for both client certificates and listening certificates as well on the Envoy side. And we're also leveraging Istio authentication policies and destination rules to enable the mutual TLS between these services. So now what exactly are the authentication policies and destination rules? So on the left-hand side here, we have the authentication policy. So this essentially tells Envoy to listen on HTTPS and also to check for client certificates. There are two modes here. One of them is strict, one of them is permissive. So if you had the permissive mode, you can actually still serve on HTTP and just plain TLS without checking for client certs as well. Then on the right-hand side, we have the destination rule. So the destination rule essentially tells Envoy which client certificates to pass while contacting the target service. So here, for example, we specify the CA, client cert, and the private key that will be used. Okay, now to get into the architecture of how basically this communication works. So as you can see here, we have service A on the left and service B on the right. So service A wants to make a mutual TLS request to service B. So the application pod itself has 3 containers within it. One of them is the main application. We have the SIA sidecar, which is the service identity agent, and the Envoy proxy. So essentially the sidecar is responsible for getting and refreshing the certificate. And then the Envoy proxy through the SDS API will essentially fetch it so that it can directly start using it. Now when service A actually wants to make a request to service B, it will essentially be routed through the Envoy proxy, and then that will establish mutual TLS to the service B, and then both sides will check for certificates. And then if that's fine, then it will be forwarded to the service B application. So the authentication rules and destination, or authentication policy and destination rules are picked up by Istio pilot and then distributed to these Envoy proxies so they know to basically enforce mutual TLS, and then also they know which certificates to actually pass. Okay, so now that we have authentication working, how do we actually get authorization? How can we actually define RBAC with Athenz? So we're going to leverage the Athenz role to actually define service authorization. We're going to leverage the policy to basically define allowed HTTP paths and methods. And basically, the destination target service will be able to add services to its role, which are able to contact it. And we're going to leverage Istio service roles and service role bindings to actually enable service authorization between these two. Okay, so now I'll show you how the mapping looks like between the custom resources, the service role to the Athenz UI. So here we have basically a service role custom resource from Istio at the top, and then we have the Athenz policy at the bottom. So as you can see here, the action from the policy will get mapped directly into the get method. And, then the path from the resource will be mapped to the path. And then the role itself will be the target service. So essentially we have each role has their own service role, and then each policy essentially is translated into the roles of the service role. Now, for the service role binding, which essentially says which users are allowed to talk to me, you essentially add these services as members to the role. So at the bottom here we have a role and the members associated with it, and at the top we have the service role binding. So here the role will be the role reference instead of the service role binding. And at the bottom, the members will be added as users which are actually allowed to talk to this service. Okay, so now that we have this translation in place, we wanted to automate it. So essentially what we did is we built a Kubernetes controller which basically automates translating this. So some of the features that it has is it watches Kubernetes namespaces, it pulls Athenz for this role and policy information, then it creates service role and service role binding, Istio custom resources. So just to give you an overview of how this looks like, so here in the Kubernetes environment, we have the controller running. It has a watch on the namespaces. These namespaces basically map to the Athenz domain, and then every polling interval is going to fetch this information from Athenz and then translate that role and policy information into the custom resources, service role and service role binding. So those will either be created, updated, or deleted. And then once we create these custom resources, then Istio pilot will essentially pick them up and then distribute the RBAC section of Envoy to the Envoy sidecars within the cluster. Okay, and now, I have a small demo of how this actually works. So I filmed a video. So essentially here, I am using, So I'm using the product page example from Istio, which essentially has some sample like product page information that calls a review service and also a details backend service. This basically shows some information about a book. And so I have two namespaces. I have a UI namespace, which is running the product page and review service. And I also have a DB namespace, which is essentially running my backend service called details. So here we have the detail service running. Now, basically, I'm going to curl the product page just to show you that it's working here. So this particular section is actually coming from the detail service. This is populated through the call to there. So as you can see from the Envoy logs themselves, this service actually returns a 200 here. So that request actually went through. Now, I will show you the, first I'm going to show the service role binding, essentially. And take a few seconds here. So here we have the service role binding. So basically the target service is the detail service in the other namespace. The user is the front end service. And here we have the Athenz UI. So this is the backend service called the DB. And we have basically the details role, which is associated with the details service. The product page is a member of that service, meaning that it is actually allowed to talk to it. It's authorized on that path. So here you can see the product page itself. So what I'm going to do here is I'm going to delete it to show you that authorization will stop working after this deletion. And just to show you, on this side, we have the associated policy with the details service, which is essentially the HTTP GET method on the /details star path, since it's making that actual request to it. Okay. Yeah, now going back to the terminal. Yeah, so just to show you, basically the controller kicked in, it removed the service role binding so that it's no longer present on our actual cluster. And now I'm also going to show you just the service role itself really quickly, which will basically show the HTTP path and method that's allowed for that service. So this is essentially what was in the Athenz UI in that policy that we saw. So HTTP GET on the /details star path, and the target service is the details service. Now, I'm going to curl product page again, and you will see that this book information that was previously populated is no longer being shown. So here, for example, you can see that the product service is unavailable because it was not able to be contacted. And just to show you, the Envoy logs, you will see that now this service gets a 403. It's unauthorized to talk to the details service now. So here you can see details, which was previously 200, is now a 403. And that is it for the demo. So this is essentially how these Athenz rules and policies are translated into these custom resources. You can see that as soon as essentially you edit the UI, the Kubernetes controller that we have running is going to create, update, or delete these service role and bindings. And then this authorization will be turned on and off. So for engineers, they can quickly go in the UI and just add what they want to authorize to their target services. And so that is it. This is how we solve authentication and authorization use cases at Verizon Media. And thank you so much. So if you have any questions, please let me know. Yes.
Quick question, how do you trigger the certificate rotation on your, I guess you have an additional sidecar in addition to Envoy sidecar?
Yes, exactly. So let me go back here. So so this is the sidecar, which is fetching the certificate here. So this one is essentially rotating it every 24 hours. So that's dynamically changing. It's dynamic, yeah. So this sidecar takes care of that. And then either through basically sharing an empty directory or the SDS API, Envoy can pick up the new certificate. Go ahead.
So the latest version of Istio includes a node agent that can do something very similar. Have you guys
Exactly,
looked
yeah.
at
So
integrating with that?
essentially, we have. So we essentially started this project, and I guess our own version of this external CA before that was ready. But now, since I guess they're finalizing the node agent, we kind of have a similar node agent as well behind the scenes here. Our target actually is when that comes out to actually hook up Athenz as an external CA directly into Citadel. So then that will be directly integrated. Oh.
Is automatically injected?
Then the sidecar also is it automatically inject into when you create the pod, or you have to do it manually?
Yeah, so right now essentially we have templating in place for our applications, so we're bundling it with every application pod. Yeah, and yeah, you can also inject it as well with a mutator. That's also possible.
Any questions?
All right, thank you so
Okay,
much.
thank you very much.